All right, guys, today we're going to be moving on to 6.2 and 6.3. We're actually getting two sections today, but that's just because both of those sections talk about parallelograms, and that's kind of the way they lay it out in the book. We're going to be talking about parallelograms today, and the mission is I can use relationships among sides, angles, and diagonals of parallelograms to find unknown values. And so this is actually kind of something that you're going to see all throughout this chapter. We're really looking at the properties of each of these figures and what makes them what they are. For example, what makes a parallelogram, okay? So we're going to be looking at those properties, and those properties are going to help us to be able to solve problems that are related to them. So let's start actually with something in chapter 3. I want to go back and just kind of take a look at something that you already know something about. And so you remember we talked about parallel lines. And again, we can kind of notate those as being parallel with the little marker here that says that they're parallel. And you remember that we talked about how when you have a line going across those lines like so, that is called a transversal. And so this creates all kinds of neat relationships among these parts. You remember, for example, if this was 50 degrees, that this would also be 50 degrees because they're alternate interior angles. Well, what I want you to think about here for just a minute is what if I had a situation like this? What if I had a set of parallel lines that went this way, and I had another set of parallel lines, we'll make those a different color, that are going this way? What kind of shape would actually be created? And if you look, you can kind of see it here right in the middle, and I will make this in red just so you can see it here. You can see that there is a shape that is created here, okay? And that shape is a parallelogram. So that's basically what the main thrust about a parallelogram is that they have two sets of parallel lines. Now, we're going to cover some other figures in the next couple of days that also have two sets of parallel lines, but they have some other characteristics that make them to be different polygons in and of themselves. And so this parallelogram, you're going to find out, is really a group of different polygons. But today our focus is just on the parallelogram itself. And so let's talk about some properties of the parallelogram, and then we're going to dive into actually some problems from your practice so that you can have a good start on what you need to be doing today. So let's just kind of draw out a parallelogram here, and I want to talk about a few things about a parallelogram. And again, just please note that I'm doing the best I can here. But with a parallelogram, there's several different things that we need to talk about that are characteristics of a true parallelogram. Remember, we have two sets of parallel lines, okay? So because of the fact we have two sets of parallel lines, there's some interesting things that happens. Number one, the angles that are opposite one another are actually congruent. So number one, opposite angles are congruent. So that means this angle here is congruent to this angle here. We could also say that this angle here, and I'm going to use 2 marks this time, is congruent to this line over here. So opposite angles are congruent. So when you're looking at a true parallelogram, and again, they sometimes they may notate these with the little parallel symbol. But when you're looking at a true parallelogram, you need to remember that opposite angles are in fact congruent, okay? Another thing that you need to think about is, we'll call this number 2, is that opposite sides are also congruent, okay? So opposite sides are congruent. So in other words, what we're saying is if I have this side here, then this side opposite it would also be congruent to it. So let's say if this is 10 centimeters, then this would also be 10 centimeters, okay? And likewise here, if we have a certain side length here, we know that that's going to be congruent or the same or equal on the opposite side as well. So again, opposite angles are congruent and opposite sides are congruent as well. Okay, there's a few more relationships here that I want to use a different one just so we're not getting too crowded here. But there's a couple of other relationships that happen as well. Remember that these are actually two parallel lines, right? And so if I'm talking about the relationship between this angle here and this angle here, then I've got to think about the fact that those two sides would be same side interior angles, okay? And there's another word that we can use for that, and that is consecutive. They're consecutive. In other words, if I had this parallelogram and I named it A, B, C, and D, then C and D are consecutive, okay? Then from here I go to D and to A, and then from A to B, it's the next one in line, okay? So when we're talking about parallelograms, we understand that consecutive angles are supplementary. I'm going to abbreviate that. Consecutive angles are supplementary. So what that means, if you remember from same side interior angles, you notice that this one is an acute angle, whereas this is an obtuse angle. So remember, if something is supplementary, that means it adds up to 180 degrees. Okay, and we're going to look at some examples of each one of these, so don't get too worried about it, because we're going to look at each one. And then the last thing that we need to think about here with parallelograms is if I were to make diagonals in this parallelogram, what we need to realize is, and that was a terrible drawing that I just did, but what we need to realize is that those diagonals bisect each other. Okay, they cut each other directly in half. And so in other words, if we have a certain measurement here, let's say 5 centimeters, then this would also be 5 centimeters. Okay, and the same thing this way. If I had, let's say, 10 centimeters here, then this would also be 10 centimeters as well. So the diagonals bisect each other. So really 4 rules we need to talk about here. We'll go over them again real quick. So when we're talking about parallelograms, opposite angles are congruent. Okay. Opposite sides are also congruent, or they're equal to one another. Consecutive angles, okay, so we would be talking about, let's call this X, and we'll call this one Y. So consecutive angles are supplementary, or they add up to 180 degrees. And fourth and last is diagonals bisect each other, okay? So probably the best way to do this, just dive in to the actual practice and let you kind of see how you're going to be applying this, okay? So we're going to look at number 1 here. And again, it's telling us to solve for X, and each figure is a parallelogram. So it is telling us right off the bat that this is, in fact, a parallelogram. So because it's telling us it's a parallelogram, we can assume all those rules are true. So what I want you to notice about number 1 is that I have side length here, that's 5x plus 1, and I have a side length over here, that's 11. Notice those sides are opposite one another, and so it goes right back to our first rule that says that opposite sides are congruent. So the way I'm going to solve number 1 is I'm going to go ahead and just set these two things equal, because congruent means equal. So I'm going to have 5x plus 1 equals 11, which means I just need to subtract 1 from both sides, and I get 5x equals 10. And if I divide by 5, I'm going to get x equals 2. And in this case, I'm just solving for x. So that's really all I have to do is just go ahead and solve for x, and I'm done. So my answer would be right here, x equals 2. So let's move on down to actually number 6 is what I want to look at next. So let's look at number 6 here. And this is a little bit hard to see, but actually what's going on here is they are saying that angle is right in here, okay? It's kind of closer to this right side than it is the left side, and I made a mess out of that, so I'm going to erase that real quick. But it's basically saying that this angle here is right here, okay? So what I want you to realize is this angle here is actually opposite this angle here. Here's another way that you can see this, okay? Notice that this is an obtuse angle, and I also have an obtuse angle here. So because I have 2 obtuse angles, those angles are opposite each other, and that means that they are congruent. Remember, opposite angles are congruent. So again, all I have to do for this one is I just have to set it equal to each other. So I'm going to have 44x minus 2 equals 130. I'm going to go ahead and add my 2 to both sides. So that's going to leave me with 44x equals 132. And then if I divide by 44, I'm going to get x equals 3, I do believe. Yep, 3. So again, I'm just solving for x, so that's all I literally have to do, okay? Number 5 is a little bit different here, and it's different because I want you to notice that these angles are not across from one another. They're actually beside of one another, okay? Also, what I want you to notice is that this one is an obtuse angle, whereas this one is an acute angle. So they are definitely not the same. But we can decide, because this is a parallelogram, that because they're consecutive, that they are supplementary. So again, you notice that we have 2 different methods based on 2 different types of problems. Over here on number 6, these angles were across from one another. On number 5, these angles are consecutive, or they're right beside one another. So for number 6, because they're opposite, they're congruent, I set them equal to each other. But for number 5, I'm not going to do that because they're not equal. One's obtuse and one's acute. So they are consecutive, which means they add up to 180 degrees. So instead of setting them equal to each other here, I'm going to do 78 plus 17x equals 180, okay? Now, what do I have to do to solve that? Well, I've got to subtract 78 from both sides. So subtract 78 from both sides, and I'm going to get 17x equals 102. Divide by 17 on both sides, and x is going to equal 6. So here, I just simply have x equals 6. So again, depending on what you're given, that's the kind of method that you're going to have to use to be able to solve each distinct problem that you've been given, okay? Now let's look down at number 9, because number 9 is actually the same type of problem, but it has some different directions, okay? You really need to pay attention to your directions and what your directions are telling you. So you notice it says, find the measurement indicated in each parallelogram. And it's asking us here on number 9 to find the measure of angle K, okay? So again, I'm still using my relationships to try to help me to know how to set it up. And really what I'm asking myself every time is it congruent or is it supplementary, okay? Congruent or supplementary. And so if I look at this one, this is actually down here in this angle, okay? It's talking about this angle right here. And you notice that's an acute angle. I also have an acute angle over here. And these angles are opposite one another. So again, what's my rule? Opposite angles are congruent. So if it's congruent, then I know that I'm going to set it equal to one another. So quite literally, all I have to do is 7x minus 1 equals 6x plus 6. Okay? Now, you've got some choices you can make about how you want to do this. I usually like to keep positive numbers. So I'm going to subtract my 6x from both sides. And that's going to leave me with x minus 1 equals positive 6. And then I'm going to add 1 to both sides. Again, the goal is always the same. Get the variable by itself. So I end up with x equals 7. Now, you may be tempted right here to say, okay, I'm done. Well, the issue is it did not say solve for x. It said find the measurement indicated in each parallelogram. And this one, in fact, they're asking us to find the measure of angle K. And so I have to take this x equals 7, and I have to substitute it back in right here, okay? So the measure of angle K equals 7 times x, which I have now discovered is 7, minus 1. 7 times 7 is 49. 49 minus 1 equals 48. So 48 is actually my answer. This is not my answer. It helps me to find the answer, okay, after I substitute it back in. So you're going to do the same thing on this group of problems. You will see number 10, again, is find the measure of angle C. Notice these two angles are not opposite one another. So again, you've got to think, if it's not opposite, then it must be consecutive, which means that it's not congruent, but it is supplementary. Okay, so it's going to have a different setup than problem number 9 is. All right, let's move on down into some other problems. Look at number 13. Oh, my goodness. Okay. And you may be thinking, oh no, what in the world am I going to do here? Well, what you're actually seeing here is you're given this angle, which again is an acute angle, and you're given this, which kind of looks like the side here, but actually it's not. I want to go ahead and tell you that it's talking about this angle right here. This is one part I really don't like about these worksheets and the way they do this, but it's kind of what we have to deal with. Okay, so it's talking about this little angle down in here, and then this 87 is this angle here. So I'm given really three separate angles if you think about it. So I've got 1, 2, 3. I've got three separate angles that I'm talking about. But what I want you to understand is all of these angles on this side, they actually make up this whole side, okay? So those angles are not the same, obviously, but we do understand that they would, if I add those together, that they are going to be supplementary. Okay, they are consecutive angles. If you notice, I've got a 57 degree, then I've got an 8x minus 4, and then I've got an 87. They're all kind of in a row. So because they're consecutive, we are going to add them up and set them equal to 180 degrees. So I'm going to take 57 plus 8x minus 4 plus 87, and all of that has to equal 180 degrees, okay? So again, now it's just a matter of collecting like terms. So if you notice, I've got 57, I've got a -4, and I've got a positive 87 that are all like terms. So if I add all those together, I'm going to get 140 plus 8x equals 180. And from here, I just need to subtract 140 from both sides, which is going to give me 8x equals 40. And last step is just divide by 8 to isolate this x. So x equals 5. And again, here I'm just solving for x. So this would be my final answer for number 13. And that's actually the same process that you're going to use for all these problems here, 14, 15, 16. Now, when you get down to number 17, I want you to notice that it looks like exactly the same type of problem, and it is. The only difference here with number 17 through number 20 is you have to find the measure of angle U. So what you're going to end up doing is after you find your answer, then you're going to have to substitute it back in. Now, you may think to yourself, well, U doesn't have anything here. But remember, I'm just going to give you a hint here. I'm not actually going to solve this one. Once you solve this for x and you know what x is, you could substitute it back in right here. And you say, well, why does that make any difference? Well, angle U is opposite angle S. So that means they are congruent. So once you find the value of x here, substitute it back into this angle S, and that will also be whatever angle U is. So let's go over that. Angle S is equal to angle U, okay? So if you find angle S, then you're also at the same time going to be finding angle U just because of the relationships. Okay, so hopefully this has been helpful. Again, you only have 20 problems. I've went over approximately 5 of them, so you really only have 15 that you have to do, okay? If you need any help, obviously reach out to us, and we would be glad to help you. Sorry for giving this to you on a Monday, but it just kind of worked out that way in the plan. But for those of you coming back in person, then we'll obviously go over anything that you're having trouble with on Tuesday. And again, those that are on NTI, please reach out to us. Either me or Miss Wheeler would be glad to do a Google Meet or answer any questions you've got if you want to send us a private comment. All right. Thanks, and have a great day today.